Lieckfeldt. My name is Uwe Lieckfeldt, and I will be your host today. I'm excited that you joined our strategy day, and we will have an interesting agenda and very relevant topics. At HashiCorp, I represent our emerging products, and in this context, we want to share with you today how you can increase security, reduce complexity, and operate more efficiently. So, of course, our objective is to provide you with insight and ideas. So please, if you have questions, feel free to ask them and share them with us. At Zoom, we have this chat functionality, so please put your questions into the Zoom chat. Fiona and I will be monitoring the chat, and towards the end of the presentation, we will have ample time to answer and to discuss all your questions. So with this, please let me turn over to Patrick. Patrick, the floor is all yours.
All right, thanks, Uwe. Hi, everyone. My name is Patrick Presto. I've been with HashiCorp now for 2 years. And before that, I've spent a lot of time dealing with application delivery, everything from sysadmin to automation, Java, .NET, moved into roles for global management over infrastructure teams. But at the end of the day, it's been a lot of automating. How do we get the development products into production, dealing with security and networking, which is why I'm eventually at HashiCorp dealing with Consul. And that's what we're going to talk about today, is how are you going to be dealing with zero trust requirements that are coming your way or have already came your way, and how can Consul help you, along with other HashiCorp tools. So I hope you guys are going to enjoy your Uber Eats voucher as we talk about zero trust. This is a quick agenda where we're going to first kind of start out on why it's important, kind of level set there, and then we're going to move into what we see as some of the principles of zero trust, because this can mean a lot of different things to a lot of different teams. We're going to double down on identity. Identity is pretty critical to understanding how you can be successful with the zero trust model outside of HashiCorp, just as a top level concept. And then we're going to start diving into Consul. So let's get started. All right, $6 trillion was lost last year, and this is why CEOs are placing cybersecurity as the #1 business risk. Cyber attacks have more than doubled in 2021, and of these, 90% are showing evidence of lateral movement. And so an example of lateral movement I like to use is the Target breach that happened like 5 years ago. That resulted in 40 million credit cards being stolen. In this example, attackers, they gained access to the target network through an exploit in the HVAC system. And from there, they waited, listened, acquired a partner's credentials that allowed them onto the corporate network, where they continued that discovery process and eventually obtaining higher privilege credentials to let them leapfrog into the payment system. And that is how lateral movement works. And there's a lot of this going on right now. And so I also like this example because a lot of companies use internet connected heating, ventilation, air conditioning systems. And we don't typically think about these as computers extending our network perimeter that we need to protect. If and when something gets compromised, we need to worry about this kind of lateral movement. And this is why we're starting to care about service mesh. Service mesh is the #2 trend according to Gartner this year. And this is also consistent with the Cloud Native Computing Foundation survey as well. And I personally feel like a lot of this is being driven by the SolarWinds breach that happened a little while ago. This supply chain attack, for anyone that's not familiar, I don't know how you couldn't be, but just in case, it left 18,000 customers vulnerable. And these customers literally had a back door available in their network that these attackers to gain access to and jump in their environment at any time. So this is a super big deal for them. And some of these customers include our government agency like the Pentagon, the Department of Homeland Security, who's supposed to protect us against these exact things. That being said, about 80% of the targeted corporations were private. Microsoft, Cisco, Intel, hospitals, utilities, telecoms, pretty much all the companies that build the backbone of our country. So we still probably don't know the long-term impact of this compromise, but what we do know is that the attack accelerated big changes in the cybersecurity industry. These 18,000 companies and agencies learned really quickly that it's not enough to build a firewall and hope it protects them. The US government even issued an executive order shortly after to improve the nation's cybersecurity. And it recommends that, hey, both public and private companies are in this together. We're all being targeted, and we need to apply fundamental principles of zero trust. That was a gross summary of that executive order, but in general, that is what it's saying. So if we agree firewalls aren't enough, then the next step is to start looking within our network. And that's exactly what zero trust makes an assumption of, that an attacker is already in our network. With a zero trust mindset, you want to authenticate, authorize, and encrypt every transaction to make it harder for any attacker to move beyond the compromised system or account. And this is what Service Mesh does for us. And so this is going to move us into our first poll. There we go. That was pretty quick. So this is all anonymous. Please participate, join in, let us know like what you're looking for out of a service mesh. I don't think there are any wrong answers, and you can pick a few of these.
Cool, I'm letting people fill it out. I'll give it just a couple more seconds, Patrick, and then share it out.
Okay. Interesting. All right. So this is some pretty good feedback, actually. So we've got a couple of folks that are pretty new here, and then, you know, basic principles of how do I support multiple ecosystems and clouds. And of course, I think what's on top of mind for a lot of management anyway is, you know, how do I not impact my developers more than they already are? How can we get rid of some of this technical debt that is related to operations and security and not their day-to-day jobs? All right, thank you very much. So now that we talked about service mesh, I want to really start talking about what we see as zero trust. Let's define our universal principles of zero trust, because like I was kind of hinting at before, this means a lot of different things to a lot of different teams. You know, it could be intrusion detection, threat detection, vulnerability testing, log and device event aggregation, all that kind of stuff. So for us, our principles are going to be really driven on things that are, you know, related to your application delivery pipeline. Everything from when you develop that application to running it in production, every single transaction that happens, we want to apply these zero trust principles on the left to every access and communication. So that's going to start with identity. That's going to be a big topic for today. Every source and destination needs an identity that we can authenticate and authorize. We want to implement a least privilege principle so that you're only allowed to talk to who you should be talking to, not necessarily your Active Directory server if that's not what you should be talking to. And this helps us limit the blast radius of any compromise. Everything should be time bound. We want, once a service is authenticated, for it to have to re-authenticate so that we can continuously verify that service's identity. And that's another big concept of zero trust, is continuous verification, so that an attacker can't come in and grab credentials and masquerade as another service. And of course, encrypt everything, both in transit and at rest. Log and audit is crucial. So those are the elements that we want to enforce throughout our application delivery cycle for all services, platforms, and environments. Now, when we start applying these principles in a small environment, like let's say a single Kubernetes cluster, it's pretty simple. If we expand that to 2, 4, 5 Kubernetes clusters, well, this gets more complicated, but the tools have done pretty well maturing in the last year and a half, and that's not that big of a problem. Let's expand this further and include virtual machines, bare metal, ECS, Nomad, that kind of stuff. Now it's starting to get really hard, actually. And if we take it one final step and we start expanding our networks into areas we don't control, maybe we're going from on-prem to the cloud or multi-cloud. Now it's starting to get really, really complicated. So we want to avoid implementing these principles in silos. What we're seeing is that there's a lot of technical debt happening here because you're getting, the cloud team or the AWS team implementing these, the Kubernetes team doing it their way, and OpenShift maybe even doing it separately, the VMware team. And then eventually there is a requirement where these services need to talk to each other, or you now have a new cloud that you have to support that you acquired somehow. And this is where it starts breaking, and then you have to redevelop your zero trust strategy. So this leads us into our next survey. Get an idea of what your environments are looking like. What kind of data center, multi-data center designs are you guys supporting today? All right. This is actually really good feedback and pretty consistent from what we see. The majority of our customers are in multiple clouds, multiple public clouds, including usually some kind of an on-prem private data center footprint. So that kind of means that we're all on this call running into or going to run into some similar challenges. Let's start with talking about the IP. Up until now, a large part of our security model has been focused on a clearly defined network perimeter. You may have heard of this concept of castle and moat, where everything inside our walls here in green, we trust. Anything outside, we don't trust. It's very binary. And if something from the outside wants to come in, it needs to go through our firewall. And our firewall is looking at that IP or that subnet, and it's filtering and authorizing requests based off of that. And so we have a bunch of applications that are typically trusted within our network, and they can all communicate with each other. In some cases, we add some network segments, and this is another form of IP or subnet-based perimeters that give us another level of isolation and security. Maybe we're carving out different environments, dev, QA, prod kind of deal. This actually works pretty well. We have some really smart network engineers and architects that have put these together over the last decade, and they do their job very well. It starts to get more complicated when we have ephemeral workloads like containers. IPs start changing, and this model isn't really designed for changing IPs. It gets a lot more complicated when we extend our network perimeter further into other data centers and clouds that we may not even have complete control over. And typically, we see that these are bridged together with something, like a VPN overlay or an SD-WAN or Direct Connect, Express Route, you name it, creating some kind of a super network. Now, in the cloud, there is no clear network perimeter or single firewall that you can route all your traffic through. We saw this through the Target example, right? We didn't even know what our network perimeter was there. And when we start looking at modern data centers, they're all API driven and logical. So many of these resources can actually expose themselves directly to the public internet, like an S3 bucket, or you're using a public module to build a database that creates a security group you don't know about. So with infrastructure as code, this can actually happen within milliseconds, and it's really hard for us to see every single surface resource that could expose itself. Now, I want to back up real quick and say that this castle moat, perimeter-based security is very relevant, and it's critical to any security model. It's just that it's not addressing this new concept these modern data centers have that really does show a lack of network perimeter. We don't have one ingress egress point anymore. So we can't just assume also, if we look at the old model, that it's not flawed. I mean, if we were to sit there and say, hey, like, for example, we can't assume everything is being patched, or manual configurations don't happen, or that there's no zero-day vulnerabilities that could possibly be exploited. And this is where zero trust takes the different approach, right? In a zero trust model, we're assuming that the attacker is literally already on our network. So let's protect ourselves a little bit better, and let's start redefining how we look at identity. As a unit of control, we believe the IP is broken, not the protocol, but in understanding who's sending the data and what is in the data. By the time we get requests, it's gone through firewalls, load balancers, VPNs that have natted or changed that IP multiple times, and the IP is more or less getting meaningless to us. Oftentimes we have services that are all running on Kubernetes or on the same IP address, multiple containers and services. Again, we have no idea what requests are actually coming to us. And these orchestrators like Nomad and Kubernetes are getting pretty complicated, and they're running across multiple subnets and dynamically spinning up new machines and nodes as well. So even at a subnet range, like, we're now expanding firewall rules to have large blocks. Hopefully that all makes sense. And this is really why we're pushing this need to focus on identity instead of IP address. Like, IPs are no longer as relevant in this ephemeral container type world. Now that leads us to our third poll. And before we kind of show how I'm going to solve identity, I want to take a quick look at what HashiCorp products are available in your environment today that you have to leverage. Kind of gives me an idea of how much time we're going to be spending on some of our approaches. All right, awesome. No one's using Boundary, huh? That's okay. It's brand new open source project, really cool. We're going to be covering it a tiny bit today, but not much. More importantly, I saw a lot of Vault users out there, which is great. For anyone that's not using Vault, it's a multi-platform cloud secrets manager that HashiCorp makes. It's typically deployed in all your data centers, and it kind of federates and talks to each other and helps you centralize your secrets management. That's my quick overview of Vault. But what a lot of people don't realize about Vault is that it's also a cross-platform identity provider. And this is going to be really key to our story today. The idea of using service identity as your unit of control is not something new that HashiCorp invented. Every cloud provider has already solved this problem. Azure uses service principals, AWS uses IAM roles, GCP uses job-based tokens with claims. The list goes on and on. Platforms have their own identity provider like Kubernetes. And the problem is these are all different identity models. None of them talk to each other. You can't have a service A, let's call it, running as a service principal in Azure, and service B running in AWS with an IAM role, and expect them to have any clue who each other are or what their identity is. Now, this is where Vault can really help us. Vault, it integrates with all identity models and many more than what you see here on the slide. It understands the cloud native identities. It allows you to leverage these, and it translates these identities into a Vault identity or a unified or global identity, whatever you want to call it, that other tools in your zero trust strategy can leverage. Like Consul out of the box can leverage this. So now service A can run as a service principal in Azure, and in a fully automated way pass its identity to Vault. Consul understands Vault identities and it's a unique global identity for that service, And it can assign the service everything it needs from policies to tokens to certs, you name it, in a fully automated way. And the same example that I just gave is true for AWS or GCP, Kubernetes, clouds and platforms, any of them. So we now have an identity broker that can enable us to span any platform, any environment. And this is the first step to implementing zero trust, is to have a solid identity as your unit of control. For us, we define that identity as something that needs to span all boundaries, all clouds, all platforms. Creating this in a silo for a single platform is pretty easy. Creating it to support multi-platforms gets harder, multi-clouds gets even harder. So this is a step that many of our customers don't realize is the answer to the problem that they may be already trying to solve. I've seen them try and solve this in one other way. I'm sure there's many ways, but the one that I'm familiar with is by setting up like an OIDC provider, and then they start using these JOT tokens from OIDC across multiple API gateways that they put out there to try and bridge these boundaries together. But this gets complicated because now not only are you managing your own OIDC provider basically, but you now need to replicate all this across all your data centers to get that common source of truth. And at the end of the day, once you have this working, you're still not relying on the native identity that your workload is being launched with. You're adding another layer of abstraction. You're making your zero trust model here, your identity, more complicated than it needs to be. So Vault solves identity across all boundaries, allowing you to connect and audit any identity source. And I think that is really the key takeaway here for any Vault users. This is not a requirement for Consul. Consul manages identity, authentication, authorization, everything for you. But if you have Vault, then you have this amazing capability of having a global identity source for you that Consul understands, and Vault can fully automate that workflow. And we can literally spend an entire session on this slide, but we're going to move forward. I just want to make that clear that Vault's integrations with Consuls allow you to fully automate certificate creation, deployment, and rotation for the Consul control plane. Every Consul client that you could have in your network, which means every machine, every Kubernetes worker node, bare metal VM, etc., fully automated, rotation included. And of course, all of the services in your mesh that require their own certificates. So from an administrative perspective, this could be a big deal. To support zero trust principles across an entire enterprise, we're using Vault to solve our identity challenge. And now that we've established a global unit for identity, we're going to start looking at service-to-service communication next. And we're going to be using Consul to solve this. And again, like Vault, Consul's platform and runtime agnostic. So you can run your services wherever you want, bare metal, VM, Kubernetes, OpenShift, DCS, whatever. Consul is going to give you a standard way to discover, connect, and secure these service-to-service communications. We're going to do a quick shout out for Boundary. For human-to-machine identity or communication, we envision Boundary playing a role here, enabling multi-factor authentication and leveraging your existing identity provider. Maybe it's Azure AD or Okta or something like that. For anyone looking at VPN connectivity, Boundary might basically replace your VPN. It would live on the edge of your network, and so you would run into Boundary instead. Big difference being, once you establish a session at Boundary, you never go past the edge of your network. You're never actually in your network. It's a proxy. It sees based off of your IDP what you should have access to, and only proxies requests to those servers for you. It integrates with all of the clouds, including Consul, to get a real-time update of where inventory lives, so it knows where to go. And if you're using Vault and you're trying to SSH to a machine, for example, Boundary has integrations with Vault that basically say, hey, oh, I see you have a Vault engine set up for this. I'm going to request those credentials from Vault dynamically generated, and I'm going to inject them into your session. And you as the end user never had credentials on your machine, never made those requests, you never even saw that. So a lot of this is happening in the back end, super secure, really cool stuff. Boundary team would be excited to talk to you about it, I'm sure. So let us know and we can get that set up. All right, so we've kind of covered identity enough. Now let's start taking a look at service mesh and connectivity and enforcing some of these zero trust principles. I've seen some common patterns in like the last 6 months. And usually it starts with, my customer having some kind of a cloud first project or a migration strategy. They want their apps to be flexible and multiple environments to be supported. So typically they start moving towards containers, and Docker is the first choice. And pretty quickly they realize they need some better orchestration, so they pick Kubernetes. And then you've got another development team that jumps in and says, oh, that's way too difficult. We're going to use Rancher to simplify some of that. And of course, someone else has a new opinion. They're more secure. They want OpenShift. They want vendor support. Now, at this point, we think things are getting better at each stage. We're standardizing on a platform, it's Kubernetes. But in reality, you're making a fragmentation problem here that is getting worse. And one example is with Istio. Now, it's a tool that's bundled in Kubernetes for service mesh. It's available in every distro. So of course, you think you can enable that in Rancher and OpenShift clusters, and we can use that to allow them to talk to each other. But the only problem here is that that doesn't actually work. When you talk to OpenShift or Red Hat support, they'll tell you that you can only connect OpenShift clusters together with Istio. Now, this is a subtle example where we're running into fragmentation among Kubernetes runtimes themselves. But I want to kind of expand the conversation out of just containers, because in reality, most environments have many other platforms you support. Databases, are on bare metal, virtual machines, other orchestration platforms, etc. So we're going to kind of just assume that as we move forward. And this starts getting things, making things a little bit more complicated. And we're going to add at least 1 or 2 clouds, like most of you on the call already have. And now things are, like we kind of were referring to before, even more complicated. This is where we start getting inconsistent workflows, because each runtime behaves a little differently. And because of that, we have to start building like scaffolding or some complex stitching or integrations to start tying things together. And now we've got a lot of really smart engineers, especially out here in the West. So when they get this working, and they will, it works really, really well. What we're learning is when something breaks, it just breaks really, really bad. And we get these really long MTTRs and these really tough RCAs to solve, because it's really hard to see how one upstream service is going to affect another downstream one when they're running in different runtimes, maybe even in different locations. It just takes time. And it gets even more complicated when we do other things that we're supposed to already be doing, like disaster recovery. So I've had some of these situations with customers, and they come in with some like a variety or one a derivative or another of this story, and then they kind of ask like, how do we support this now? And this leads us to our last survey. Real quick, how do we support this now? If you had to implement or use a service mesh today, what would be your biggest concern? And for those of you that are already running a service mesh, maybe what is your biggest challenge in supporting it? And if you want to click other and you want to throw some topics in conversation in chat, please do. And hopefully for anyone that is playing with service meshes today, that last slide kind of resonated with you just a little bit. and is kind of highlighting some challenges that you might be seeing. Yeah, observability and troubleshooting. Yeah, it's a big one. Okay, great. Thanks for the feedback. So let's jump in and let's take a look at how we're solving this at HashiCorp with Consul Enterprise. For anyone that doesn't know, I mean, now we're gonna do a quick overview of Consul. We're gonna show the possible, and then we're gonna dive into some of the core use cases next. So Consul is an agent-based technology. The agent's deployed across all your runtimes. And remember, Consul's runtime and platform agnostic. It's a Go binary. You can deploy it anywhere. And now every time a new service is launched in real time, that service registers itself to Consul, and it has an identity. It gives its location, its IP address to Consul, and it's also health checking itself and others and its neighbors. So it gets its real-time health status to Consul within 200 milliseconds, right? So this is really cool. Now we have this centralized global service registry, and this enables service discovery, which is basically the foundation of our service networking platform. From this platform, we can address many different use cases, and one of them is service mesh. So moving into service mesh, Consul can be our service mesh control plane. The control plane is basically the brains of your service mesh. It knows what needs to get done, right? And it's going to give you a unified way of managing and controlling all service communication. It's going to handle service discovery, authentication, authorization, traffic routing, and it's all using the service's identity. Now, it's really important to understand this next piece. Consul doesn't depend on any cloud identity provider or any platform like Kubernetes for discovery and identity, authentication, authorization, or any of that. It's managing it itself. And this makes it different from a lot of other tools and solutions out there. And because it's managing all these itself, that's what allows it to easily extend your service mesh past any network boundary or platform or cloud. Like all of these are limiting other solutions, challenging them, building edge cases. But for Consul, we're already handling the identity and discovery, authentication, authorization, and routing. So it actually makes it pretty easy for us to move into all these places pretty seamlessly. So the Consul control plane knows where every service lives across your various platforms and clouds. And in this diagram, you see GCP, Azure, AWS clouds. They would all have their own Consul cluster. We would put a Consul cluster in every cloud or region, and the Consul clusters talk to each other. And so you could go to any Consul cluster, like pick one in Azure, for example, and you'd be able to see the global picture of your entire. You'd see everything in AWS, GCP, on-prem. You see all your services in one snapshot. It doesn't matter which data center you go to, and that's how Consul works. It sees all services everywhere. So if you ever did need to route, from on-prem to AWS for whatever reason requirement you have, that's how it works. It has a master registry of all your services. It knows where they are. It knows how to route when it needs to. So now that OpenShift workload, if it needs to talk to a VM in Azure, well, the app doesn't need to know anything. It just passes the traffic to Consul, and Consul routes it to the service that lives in Azure on a VM. So although Consul is an agent-based technology, and that's what we're talking about right now, there are a lot of situations where you can't install an agent. For example, cloud native services like RDS or serverless functions or caches, things like that. Maybe you have legacy applications or on-prem databases you're not allowed to touch. Consul can allow these services into the mesh so that they can take advantage of these zero trust principles that we're trying to enforce through what we call, Consul gateways. We have a bunch of them, and we're going to kind of cover one of them right now. just in case that wasn't clear, the Envoy data plane, this part, I forgot to kind of like highlight that. When any service enters the mesh, it's going to talk through an Envoy proxy. And so this Envoy proxy is going to be deployed to your container as a sidecar, or you know, a daemon that's running on a VM, whatever that is. And that's how your application is going to communicate. And we're going to kind of dive into how service mesh and how Envoy proxies work in a future slide. So here's the art of possible. This is actually a diagram that's showing our advanced Consul enterprise workshop that I've given with my customers. And in this workshop, we built 3 data centers across AWS, GCP, and Azure from scratch. Initially, the data centers have no IP connectivity or any routes. They live in different regions, and we use Consul Enterprise to connect them all together. And to do this, we start with a Consul mesh gateway. And so if you take a look at the cloud in the middle and the 3 gateways that are connecting, that is the Consul mesh gateway. Now, these basically become the logical in and out points of the data center, who can't normally talk to each other. And these gateways, they are scalable. So in reality, you probably run a few for high availability and to provide additional bandwidth. In the workshop, we only run 1. We don't need the bandwidth, but these connect us. And if we kind of drill in and we look a little closer at the AWS box, we're using Terraform to provision our entire infrastructure within this workshop. And we share all of that with you so you can kind of see how the magic happens. In AWS, we've decided to run our payment API off of Nomad. HashiCorp Nomad is our scheduler. And we're also leveraging Vault, like we discussed before, and it's acting as an identity broker, allowing services to authenticate against the native AWS IAM model. And then using that as a Vault identity, we're authorizing our services with Consul in the service mesh, and it's fully automated. We show you how to make all that work. Another piece here is this payments API. If you look at it, it needs to use a cloud native service, the AWS Elasticache Redis service over here, but that has no agent. It's not in our mesh. And so we have what we call a terminating gateway here. And this gateway can run on anything. In our lab, we're running it on a VM. But the payments API, it says, hey, I need to talk to the Redis. And Consul knows, hey, this is external. I'm going to have to route you through a terminating gateway. And the terminating gateway is now able to look at it, end the MTLS connection, and enforce one-way policy and say, hey, are you supposed to be talking to Redis? Do I have a rule that permits that? And if I do, okay, I'll allow it to go out. But between the terminating gateway and Redis, that connection, that is outside the mesh. That could be anything. It could be TLS, it could be raw HTTP. You could create your own MTLS connection there if the service supports it. But this is a good example of 2 different gateways. The mesh gateway is what we use to connect regions and data centers all together. And the terminating gateway is what we use to allow services to jump out of the mesh securely and with policies to external services like cloud services or maybe legacy services. And what's not in this workshop is the ingress gateway, which is the exact opposite. Maybe you have other legacy services that have not made it into the mesh yet, and they need to jump in and talk to services in the mesh. In that case, you'd use what we call an ingress gateway. So we can really support, you know, legacy services coming in, mesh services coming out, and connecting all this together. The only downfall for this lab is it is a 4-hour lab. It does take a while to build all this, but like I said before, we are literally building it from scratch, everything. And so now I want to jump in a little bit more about Consul and the primary use cases for Consul. So what we already discussed, every service has an agent. Once that service starts, it registers into Consul, and now we get this global centralized service registry. that we can use to see what's where globally and discover these services. And with this as our foundation, we can support service mesh. And we can also support network infrastructure automation, which may not be in line with zero trust, but definitely a great use case and strengthens your security posture. I want to take just 2 more seconds here and kind of cover service discovery, because this is a fundamental element within Consul, and it's great to have a baseline here. So we have service A and it wants to talk to service B, and typically you'd see a flow like this. We go through a DNS request to a load balancer virtual IP and DNS, and the load balancer does all of its magic for us and routes the request to B. But now when we start implementing Consul, each of these services has an agent, registers to Consul. Now Consul knows their health and their location. Consul has a DNS interface. It allows us to look up these services using basic DNS. So now we're going to use, hey, I want to connect, A wants to connect to B. I'm going to use the .service.consul domain, and I'm going to find the IP address and be able to connect to it. If I spin up 3 more instances of B, no problem. Consul uses a weighted round robin load balancing algorithm and will give me, will shuffle the traffic accordingly. If an instance goes down, then it's not going to provide that to me through the DNS interface. So I'm always being routed to a healthy instance, just like a load balancer, except without the hop. And that's how service discovery works in general. Now, service mesh is basically offering the same things, but it's going about it in a different way. So now when A wants to talk to B, we need to go through a proxy. A thinks it's talking to B, and the proxy intercepts that traffic. And like I was talking before, Consul is our control plane. It's the brains of the operation. It knows what needs to happen. The proxy, it knows how to do everything, but it has no idea what to do. And so our control plane here is going to inject that proxy with all the information that it needs. The certificate for its identity, the routing rules, so it knows where other service proxies live, and other rules like policies that allow it to know who's allowed to talk to it. So this policy or a proxy tries to talk to B's proxy, and it's able to find it through the mesh. And it has a certificate, and so does B. Both proxies have certificates from Consul that are signed by the same CA. So we establish a mutual TLS connection. Now, before we actually proxy on B establishes it, the proxy on B, it's going to look at its policies, which we call intentions, and say, oh, is A allowed to connect to B? And if it is, then we establish a connection, it's authorized, and A is now talking to B, and it has no idea of these proxies. Neither A or B has any idea that there's proxies involved doing all this. The one other piece for service mesh, I did see a couple of people talk about traffic routing. These proxies are layer 7 envoy proxies. They are really intelligent when it comes to traffic shaping. And so you can have version 2 of B get deployed, and you can tell Consul, hey, I want 10% of my traffic to go to version 2, and I want to slowly scale it up over time. We can support blue-green deployments, A/B testing, canary deployments, all kinds of different models. So there are a few folks that are trying to deploy mesh to take advantage of some of this network routing capability. The last use case that I want to cover today is around network infrastructure automation. Not every environment can just jump right into service mesh. And you already have a lot of firewalls, network segmentation, and load balancers out there that you might need to be addressing as you migrate into maybe a more modern service mesh style. And it's really good to know that with Consul in your infrastructure, you have this centralized registry of services. We have a new feature called Consul Terraform Sync. And with Consul Terraform Sync, this is a daemon. It can run on any platform, and it's listening to your service registry for whatever you tell it to listen to. In this case, it's listening for service A and B. And Consul Terraform Sync is configured to point to a Terraform module that you already have. Maybe you're using Terraform Cloud for Business, or enterprise versions, and you have a private module repo, or maybe you're pointing it to a GitHub repo. Either way, this module is static and it's defined. And the second that Terraform clouds or the Consul Terraform sync sees a change in the registry, it'll take the data, the most latest accurate data in the service registry, and it will run that Terraform module with it. And that module in this case might be updating a Palo Alto firewall rule with the latest instances of B that just got spun up. And maybe it's also updating your F5 load balancer. So Terraform has over 1,500 providers. Almost any item you have out there in a cloud on-prem data center that has an API probably has a Terraform provider already. So you can actually automate a lot of these traditionally ticket-driven manual processes. And when I talk to a networking team about this, they say, hey, I already have a Python or another type of script that does it all. It only takes me 30 seconds. I don't really see the use of this. I try to remind them that usually that 30 seconds is just for the change, but what they haven't gotten rid of is the process. The amount of time that it takes for the change window, the approval, you're pushing stuff in source control. You're getting someone else to approve and review and verify that there wasn't a manual mistake in it. And then once that change window hits in 2 days, a week, or 2 weeks, then it takes 30 seconds. Well, with this, you pretty much eliminate that whole process for repeat work, and you really strengthen your security model, because now it's all automated and it's really obvious when something's changing outside this process. Not to mention you're removing the manual touch points, which we all know comes with risk in itself. So just to summarize, HashiCorp Consul establishes a single control point for all infrastructure. It can reduce complexity from the fragmentation of different platforms, even Kubernetes runtimes. And we remove a lot of technical debt from development by eliminating the security and the operations and any type of encryption level stuff that they have to do today to meet those requirements. We talked a little bit about end-to-end automation of the network infrastructure just now. And I just want to reiterate that our whole focus with Zero Trust is to lock down these core principles: identity, authenticate, authorize, time-bound credentials, encrypt everything, audit and log everything, and not to do it in a silo, but look at an enterprise-wide view. All right, that is all I have. I didn't dive into too much detail into our different gateways and a few other of the more networking workflows and architectures, because I think we are at time.
Okay, yeah, thank you, Patrick. This was really insightful. So now for the audience, I hope that attending our strategy day was valuable to you, and that you got some insights from Patrick that you haven't considered before. And also, as Fiona mentioned, prior to the session being started, we are recording the session, and we will share the recording with you, and we will also share the slides with you. So now we have a few more minutes, and as I mentioned, I was watching the chat to see if there were any questions. There weren't many. Brian, I saw your comment about big IP and the network infrastructure automation. So I want to reiterate that we have plenty of Terraform providers, not just for big IP and F5, but for a lot of other network elements as well. And that also Consul Terraform Sync is available to download. So I would encourage you to try this, test it, or get back to us if you are more interested in digging deeper. So